A castle is surrounded by a circular moat which is 5 meters wide and 2 meters deep. The diameter of the outer edge of the moat is 50 meters. Find in kiloliters the quantity of water in the moat. So hopefully you know what we mean by moat. So it's sort of a big sort of circular canal type thing around the property, and you have your drawbridge, and it used to keep intruders from coming into your castle. That's the point of a moat. We need to try and work out the volume of the water. So you need to work out what shape we're dealing with. It does say, you see that keyword circular. So we need to try and draw some kind of diagram that's going to tell us what we're dealing with. So this moat, it's sort of, so this moat kind of comes around like this, and then you've got a inner circle like that. So then it kind of goes down something like that. So you've got this, I would imagine, grass either side, or land. Your castle's sort of in the middle here, and then the land. I'm not going to attempt to draw a castle, but basically we need to work out the volume of this sort of expanse here. So that's water on the top, and then that water goes all the way down, but it doesn't go inside. It's like a tube of water surrounding the whole castle and the grounds. So we need to work out the area. So it's sort of a complicated prism, because it's a cylinder with another cylinder missing. So you could even work it out like that. I'm not going to. I'm going to use a kind of prism approach. So I'm going to treat this as something with a cross section that looks like this. So cross section, that's not the best drawing, but it'll have to do. So this is our cross section, and as you're looking, imagine you're looking straight down at the moat, and then this has, we're told, the outer radius, so from the centre, so the middle of the castle, right in the middle of that circle, we are told, we're told this diameter is 50 meters. So from edge to edge, going through the middle is 50, so this must be 25 meters there, so that outer radius. Then you know that it's 5 meters thick all the way. So if I kind of draw this inner radius here, well, if this is 5, this is 25, that leaves 20 meters there. So the volume of a prism, so anything with a constant cross section, in this case a sort of circular ring, anything with a constant cross section, doesn't change size, going all the way through it, the volume is area of cross section times the length, as in the length that that cross section goes through the shape. So the area of cross section is going to be the area of this circular ring, which it's going to be a little bit complicated, but not too bad. And then the length is going to be, well, this here, it's going to be how deep this moat is, which I think we're told in the question. It's 2 meters deep. So this is not drawn to scale, obviously, but this is 2 meters deep. So once we work out the area of this ring, we can times it by 2 meters, and that will give us the volume in meters cubed. Then we've just got to think about kiloliters. So area, and I'm saying area, this is the area of that ring. Well, it's going to be pi times the big circle squared. So pi times 25 squared minus pi times 20 squared. So I will do a little bit of a factorization for this, just one line, just because I've seen it come up so many times where you have to recognize the difference of 2 squares. So I've seen it in the algebra quite a lot on IGCSE papers. So you could say, well, that's pi 25 squared minus 20 squared. Now I'm not going to go any further, but say these were letters, you might have to then form 2 brackets. Just remember, the difference of 2 squares is something that examiners love to test, and it comes up all over the place. But this is a calculator question. I'm just going to work that out. So 25 squared minus 20 squared is 225. So this is pi times 225. So equals 225 pi, and that's area in meters squared. Now what you don't want to do is work out what is 225 times pi. That would not benefit you in any way. If you're going to use a number in calculation, which we are, then just leave it like that. So the volume now, remember, it's just area of cross section, which we have, 225 pi, times length, as in the length that this cross section goes through the shape, which is 2. So it's 225 pi times 2 equals 450 pi, and it's meters cubed. Now we just have to think about kiloliters. So hopefully you remember, I told you that 1 cubic meter is 1,000 liters. And I told you that 1 kiloliter also equals 1,000 liters. So looking at that, well then 1 cubic meter must equal 1 kiloliter as well. So this actually already is in kiloliters. So the answer is 450 pi kiloliters. And now it's probably a good idea to get your calculator and turn that into a decimal. We haven't actually been told what format we want it in, so potentially that might be good enough. But let's assume it said give your answer to 3 significant figures. So you need to work out, well, what is 450 times pi? Well, that is 1413.716694. So to 3 significant figures, you find the third significant figure, it's the 1. You look next door, it's a 3. 3 won't do anything to a 1, so it's going to be 141, and we need a placeholder because this has to be 1,000-ish. So that many kiloliters. So quite a lot of water in that moat.